Hello guys, and welcome to another biology class. And of course today we're going to be looking at evolution. Okay, I'm very sure that a lot of you have been waiting for this topic. All right, so today we'll deal a lot about evolution. We'll go as far as we can. We cannot finish it in one class, all right, so that the video will not be too lengthy. Okay, we'll try as much as we can to go as far as we can, all right? But do not forget that these tutorials, this video lesson, these episodes, all of them, they are brought to you by the O3 Schools app. All right, so we have the JAMB app, we have the WAEC application, and these two applications can suffice for any O-level exam. You can use it for NECO GCE, can use it for GC, can use it for NAPTEC, okay, and all other O-level examinations. All right, so please, this is an opportunity for you to pass your exam at once. Okay, if you have made a conscious decision that this exam you want to write, JAMB, WAEC, NECO, NAPTEC, okay, you want to pass it at once, please download this application. I cannot tell you more than twice. Okay, I'm not putting water in my mouth before I'm telling you this. Download the app, activate it, use it effectively. Okay. Usually you are supposed to look at a question from the app, all right, but we are going to leave questions, all right, for a particular episode. Okay, we are going to dedicate one episode to answering questions on evolution. All right, so let us just open our hearts to learn. All right, then we'll dedicate a full episode to answering questions from WAEC, from JAMB, okay, about evolution. All right, so please download the app. The app has everything you need to succeed in your exam. All the past questions for all the subjects are on one application. It's a bomb, okay? Likewise, there are some wonderful features like the question search feature. You can search for questions according to topic, okay? And all the questions that JAMB or WAEC has set, okay, pertaining to that topic will come out for you to answer. So what you can do now, if you have the application, go to the app, click on question search, click on biology as a subject, then search for evolution. You see many questions that JAMB are set on evolution, both the WAEC also. Okay, you see many questions. So all you need to do is to answer all of them after we are done with this class. This will build your confidence towards the exam. Likewise, we have the classroom feature. The classroom feature has the latest JAMB syllabus. It has lecture notes or class notes that have been structured according to the JAMB syllabus. There are video lessons on the application, all right, on the classroom. And then likewise, there's a study plan. That study plan, you can create a timetable that you can easily use to finish the syllabus. Many of you made the mistake of preparing for your exam without to finish your syllabus, and that is a very, very bad thing, all right? It will hamper your performance, okay? If you want to perform optimally in JAMB, you must ensure that you finish your syllabus. Then likewise, what's more, there's a mock challenge, okay? On the app, on the WAEC app, on the JAMB app, there are mock challenges every Saturday, okay? Participate in the mock challenge to increase your competitiveness and your thinking level, okay? Increase your speed. Practice like normal exam, okay? That mock exam is an avenue for you to test yourself, all right? So if you partake in today's mock, for example, you score 20, next one score 30, next one score 50, next one score 180, score 200, you score 250, you know that you are progressing and all your preparation is not in vain. But if, for example, you are scoring, in the first mock exam, you score 300, okay, next one you score 250, you score 220, 210, you know that you are coming down and you need to buckle up, all right? So the mock exam holds every Saturday, all right, on the application. So that is the main reason why you should have the application. The app, the mock exam, you see JAMB, re-JAMB questions, okay? JAMB exam question, past questions, likely exam questions, okay? It will place you, okay, to put you in place of the examiner, be able to see how the examiner is reasoning, how he may want to confuse you. So please download the application, activate it. To activate your app, message this number on WhatsApp, 09121515246. There's nothing like scam here. Nobody wants to scam you, all right? So message that number or click on activate on the application after downloading it. And immediately you have clicked on activate. At the top, you find where the road buy activation key. Click on it. You see the option that you use to activate. Click on buy transfer. You see the account number. You see the correct amount. Make your payment. Feel free, make your payment. Send the receipts to this number on WhatsApp and you will get urgent attention. All right. So please, the ball is in your court. Roll it however you want. Okay. So let's go to evolution. So evolution is a topic that a lot of people find very boring. A lot of people do not like it. They say in boring. I'll try as much as possible to be slow, okay, with this class, because a lot of you see I'm very fast. And evolution, we're going to do a lot of talk. There's no calculation here, okay? We are talking and talking and talking, all right? But of course, the main points have to be delivered to you in the best possible way, all right? So it's a topic that people find very boring. In fact, a lot of people do not even understand itself, okay? Because there are so many dates when it comes to evolution, sorry. There are so many dates. Okay, there are so many theories. All right, so a lot of students is something they don't really enjoy. Okay, but evolution is very, very, very important. All right, so it's formed the foundation for several things, and it is very important that you know what evolution. All right, so I'm sure that a lot of you be thinking that evolution is the formation of complex substances from simple forms. All right. That from complex, a lot of you think is from complex to what? To simple. Okay, sorry, from simple to complex. Okay, from simple to what? To complex. That the formation of complex form from simple forms. Okay, but of course, evolution has nothing to do with what? To do with complexities. Okay, it has nothing at all to do with complexities, because if it has to do with complexities alone, that means that simple life forms that we see today, like bacteria. All right, we see bacteria, okay, we see viruses, okay, we see what? Protozoans, okay, that means they will not be in existence, all right? If evolution is about complexities, okay, it means that what these simple life forms will not be existing. But if you take a look around today, all right, you see discover that what these simple life forms like bacteria, like viruses, like protozoans, all of them, they are still readily available and alive, even right now that you are speaking, okay? That you are sitting down, you are watching, wherever you are watching from, all these simple life forms are still available, okay? So evolution is not about what? Complexities. Evolution is a process that has been happening. It's a process that will keep on happening, okay? Evolution is a process that will never stop, okay? Evolution will never stop, okay? It's a progressive process, okay? It's a progressive process, all right? It's something that has been happening right from the days far back, okay? That is something that is happening right now, and it's something that will continue to happen, okay? The process never stops. Evolution moves in the forward direction. It moves in the forward direction. It is what? It is progressive. It is progressive. I'm sure you have heard of Dollo's law, right? Dollo's law, all right? Have you heard of Dollo's law? Okay, let me just quickly explain Dollo's law, all right? Because it serves what? The purpose of what we're discussing today, all right? So I've discovered that many of you do not support what we are doing here. You don't like our videos, you don't subscribe to our channel, you don't share the link of our video to your friends and loved ones, okay? Please, that's very, very wrong. Liking this video, what? Will make this video to be easily suggested to students who are preparing for this exam like you, okay? So please, the least you can do is to like the video, all right? Also, subscribe to the channel, wherever you're watching from, YouTube, TikTok, Facebook. Follow us, like our videos, share the link, okay? That is the least you can do to support us. Please, if you say send us money now, you know we say you go send. So please, stop whatever you're doing, like the video, share the link, subscribe to our channel, and then what will continue. So we're talking about what? Dollo's law, all right? And the reason why we're talking about Dollo's law is because we are talking about the fact that evolution is a progressive process, right? Evolution never stops, okay? So let's look at what? Dollo's law. And Dollo's law states that once a structure or trait is lost in a species during evolution, it can never return in the same form, okay? He's saying that once a structure or trait is lost in a species during evolution, okay, it can never return in the same form. Okay, so that is what Dollo's law, okay, is all about, all right? It's an evolution principle, okay? It says that once a structure or trait is lost in a species during evolution, it can never return in the same way. Meaning that what that evolution is what is a one-way process. It's a one-way what process, okay? There's only one way. It's progressive, okay? It moves in the forward direction. It never stops, okay? So once a trait or a structure is lost, okay, in a species during evolution, it can never return in the same form. An example is what is whales, okay? Like many was years ago, all right, ancestors of whales, okay? They usually had what legs, okay? They had what legs, okay, that they use on the land. But over time, millions of years after, okay, whales what adapted to what to the aquatic what environment, and then they lost what this leg, okay? Now this leg can never return, okay, to the whales in the same what exact same form. All right, that's an example. Even horses, okay, your horses, all right, horses usually have what many toes, okay, but now they only have what one hoof. Okay, they only have one hoof now. Now those toes that they have lost, okay, cannot return in exact same way. All right, that meaning that what that Dodo's law, okay, was what we're proving what's right. Okay, that's what once a structure or trait is lost in a species during evolution, it can never return in the same exact what form. It helps to what to explain why evolution does not go backwards. Okay, like I told you, evolution is what is progressive. Okay, that it moves in the what in the forward direction. All right, it does not move what backward. It is progressive. Okay, it shows that what that evolution does not what go backward, but rather it is what it is progressive. It also helps scientists to understand what fossil records. Okay, fossil records and evolutionary history. Okay, all right, since we know that what evolution is progressive, okay, it helps what scientists to understand what fossil records and evolutionary what history. Also, evolution is what is not predictable. Okay, it is not predictable at all. All right, it tells us that what evolution is not predictable. All right, it is not predictable, and it is not what reversible. You cannot reverse it. All right, it is not reversible, not what reversible. Okay, so that is what Dollo's law in a nutshell. All right, for example, a very good example in Dollo's law is, for example, if I draw, let's say a human being like this now, having eye, nose, okay, all right, then having hair, all right, just be looking at what I'm drawing, though. Okay, I'm drawing what you now. Okay, this is what a human being now with hand like this. Okay, if I decide to what erase, let's say, remember when you usually use what your cleaner or your eraser to erase what your workbook. Okay, for example, now if you erase this diagram now, I want to redraw it. Okay, you can only draw something similar, they cannot draw this exact same thing. That is what Dollo's law is trying to explain in a nutshell, okay? That once a structure or trait is lost in a species during evolution, okay, it can never return in the same exact form. It is the law of evolutionary irreversibility, okay? The law of what? Evolutionary irreversibility. Okay, it's trying to tell us that whatever is lost, okay, and then whatever has happened has happened. Okay, so that's what Dollo's law in a nutshell. It is important to know also that nothing is freely decided in evolution. Okay, you as a human being, you that are watching this video, you cannot evolve. All right, I myself cannot evolve. Okay, so it is it's a population that evolves. Population. It is a population that evolves. Okay, you cannot evolve, I cannot evolve. Okay, but a population can evolve. Evolution is with respect to successive generations. Okay, it is with respect to successive generation, not just only you. Okay, not just me alone. Okay, a population with respect to a successive generation. With respect to successive generation. Okay, it's not just about you and I alone. right? So evolution what tries to what unfold, okay? It unfolds, okay? It what? It unrolls, okay? A lot of what? Hidden things, all right? That's what evolution does. It reveals hidden potentials, okay? And of course, step by step, okay, it begins to what? To reveals what? Hidden ability within oneself. That's what evolution does. And mind you, evolution does not only happen to us with living things, okay? It also happens with what? With non-living what things, okay? It happens with what? Also with non-living things, because over time I've also seen that what even stars, okay, can evolve, okay? Stars, they can evolve. We have what we call stellar evolution, all right? Stellar evolution, okay? Stellar. Okay, all right. So stars can also what evolve. Man has always been curious about what how the universe what came to be. Okay, is this the only one that we have? Okay, are there other universes somewhere? Is the universe expanding? Are we the only ones, okay, that live what in this universe? Are there other people that are somewhere that we have not found out? So many questions. Or does the universe what exist what somewhere else? Okay, even what the origin, okay, how God created the world, all right? Could it be true or false? Okay, was it the fear of man that made God? Was it man that made God or God that made man? So many questions about what evolution, and of course, we'll try as much as possible to what to deal with all of these questions, okay, in the teaching about what evolution. But note that nothing in biology makes sense, all right, until you understand what evolution. Nothing at all in biology makes sense until you really understand evolution, because that is the beginning, all right? So it's as simple as that. Now, what is the origin of the huge universe that we see today, okay? What is the origin of the universe? Okay, so I'm sure that you must have had your own thoughts. Okay, what is the origin of this very massive universe that we find ourselves? How would it have been created? How many galaxies are there? Okay, we have many planets. Are there some that we have not even still be able to discover? Okay, how many planets do you have? Is it 9 or 10? Okay, you know that my very earthly mother just showed us 9 planets, okay? It's Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto, okay? These are 9 planets, okay? My very earthly mother just showed us 9 planets, okay? That's a code to remember the 9 planets, okay? My very earthly mother just showed us 9 planets, okay? Mercury, Venus. This is Mercury, Venus. This is Earth. This is Mars. This is Jupiter. This is Saturn. This is Uranus. This is Neptune. This is Pluto. Okay, my very earthly mother just showed us 9 planets. So how many galaxies are there? The planets, how many planets are there? But the thing is that people say that it is related. Okay, the origin of the universe is related to what we call the Big Bang. Okay, I'm sure that you must have heard about the Big Bang severally. Okay, even there's a movie on Netflix, okay, that's called the Big Bang Theory, where many of these theories were spoken about, all right, in many of the successive episode by Sheldon. All right, so what is the Big Bang basically? The Big Bang is the leading scientific explanation of the origin of the universe, okay? Is the leading scientific explanation of the origin of the universe. Okay, so that's the Big Bang, even from the word, okay, you can get some ideas, okay? Is a leading scientific explanation of the origin of the universe. The Big Bang is a single huge explosion that happened what several millions of what of years ago. It is a single huge explosion. Single Big Bang is a single huge what explosion. Okay, you cannot what imagine it. Okay, it's unimaginable. Okay, very huge bang. Okay, just imagine how what balloon, right? You pump your balloon, then what? Before you know, you did not expect it. Yeah, okay, or oh, okay. So that is what the Big Bang is. A what single huge explosion that happens. What cause CROES cause of years ago. Okay, it's a single huge explosion that happened what course of what of years ago. Course of years, as you see here, talks about what a geological time scale. Talks about a geological time scale. Okay, that's what course of what of years. Talks about a geological what time scale. Talks about what the very long history of what of the earth. All right, and the what and the life on it. Okay, course of year. One course of year, one core. Okay, it's like what 10 million years. Okay, one core. Okay, it's what like what 10 million years. Okay, so that's why we are saying was a geological time scale. Okay, the life. Okay, that was what was on the earth. All right, so that is what course of what of years is what 10 million years is what is one core. Our universe is approximately 20 billion years. Okay, our universe is approximately 20 billion years. Do you know what that is? Okay, that is massive. Okay, 20 billion years. Our universe is approximately 20 billion years. Approximately. Okay, our universe is approximately 20 billion years. At that time, different planets world would have been formed. Okay, different planets would have been formed. Okay, and of course, the condition of what of this planet, okay, will have been what different at that time, and even over time, the conditions also must have changed. Many types of galaxies will have been formed. Okay, many planets also will have been formed. There might have been water in some planets, and in some other places, you will not find any single water at all. Swelling masses of gases might have condensed, forming what galaxies, forming what planets. The galaxy that is what for us, okay, that we are on is called the Milky Way. Milky Way what galaxy, okay? But know that what this is not what the only type of galaxy that's available, okay? We also have one we call Andromeda. Okay, Andromeda galaxy, okay? But the galaxy that is ours, okay, is the Milky Way galaxy. An interesting thing is that our Earth will have been formed, okay, like 4.5 billion years ago, okay? Our Earth, okay? This one is what? Is for the Earth. This one is universe. We say our universe is approximately 20 billion years, okay? Our Earth, okay, approximately 4.5 billion years. And at that time, the conditions were different. And even more so, okay, the conditions have been changing over time. At that time, temperature was very, very high, okay? There was so much heat by volcanic eruption, okay? Heat by volcanic eruption. Okay, so this 4.5 billion years ago, okay, that the Earth also was formed, all right, there must be the temperature would have been very, very high, okay, there must have been by heat, there must be heat by volcanic eruption, and everything was in gaseous state, okay, everything was in gaseous. Okay, in gaseous state, okay? Everything was in gaseous state as at this 4.5 billion years ago when our Earth was formed. There was abundance of Of methane. Okay, of methane. Okay, abundance of Ammonia. Okay, abundance of hydrogen. All right, abundance of water vapor. All right, and no free oxygen. And no free oxygen was available at that time. okay, available at that time. Okay, there must have been abundance of what of these gases, okay, methane gas, ammonia, hydrogen, water vapor, and of course there was no free oxygen available at that time. And if oxygen was even available at all, to be in what, in a bound form, okay, it will exist as metal oxides. All right, and if oxygen that we're talking about that was not freely available, it was not freely available at that time, all right, if it even exists at all, it will exist in the what, in a combined form, okay, as what, as metal oxides. The ultraviolet rays that were coming from the sun must have broken up what, water into what, hydrogen and what, and oxygen, which are obviously what, the component of what, of this what, water. Okay, the UV rays, the ultraviolet rays, okay, from the what, from the sun, okay, must have what, heated what, water and broken it and splitted it into what, hydrogen, what, and oxygen. All right, and of course, oxygen also must have combined, okay, with what, with other things. And since hydrogen and oxygen were what, were lighter, okay, they must have escaped. Metal oxides must have been formed, okay. Even carbon dioxide and what, and oxygen might have combined, okay, to give what, ozone, okay, and what, surround what, the primitive what, atmosphere. Many years ago, ozone must have been formed, okay, and the conditions of what, or the primitive what, atmosphere then, all right, will have been, for example, they will have been very, very hot, isn't it? They will have been very, very strong heat, okay? From what? From volcanic what, eruption, just like we have discussed, okay? From volcanoes that are exploding, okay? So the conditions of the primitive atmosphere as at then, we're talking about what, primitive condition of the primitive atmosphere. Okay, so the primitive atmosphere then, okay, so there must have been what, heat from what, from volcanic eruptions. All right, volcanoes will have been what, be exploding. Okay, all right, molten lava, okay, must have been what, scattering what, here and there. All right, and as even on top of all of this, acid rain must have also be forming. Okay, this was the condition of what, of the primitive atmosphere as at then. Over thousands and millions of what, of years ago, water also would have also what, be formed. Okay, you see the sky will what, will turn blue, due to which when the temperature will decrease, water vapors will condense and now form what, water. And then of course we will now be saying that, oh, that water, all right, you'll not be hearing that when they say that water is what? Is life. All right, water is life. If water came, it means therefore that what? That life must have come also. It means also that what? That life must have what? Must have begun. Life originated approximately 4 billion years ago. 4 billion years ago. Okay, approximately, please. Approximately. Okay, life originated approximately 4 billion years ago. We say the universe, okay, is what, 20 billion years ago, approximately 20 billion years ago. Okay, we say the earth, okay, 4.45 billion, approximately 4.5 billion years ago. Please take note of what, of all of this timeline. All right, okay, it is important as well that you take note of them. But how did life first come into existence on what, on the earth? It's a question that what, a lot of people have asked. How did life originate? Okay, and then different theories, okay, have been postulated, all right, about the origin of what, of life. Okay, we have the biblical version, which is what we call the theory of special creation, okay, in which what Father Suarez was a major proponent of what, of these. Okay, origin of what, of life. Okay, we have the theory of what, special creation, the theory of special what, creation. Okay, it's usually what attributed to to Father Suarez, Suarez. The Bible mentions what this one, all right? Okay, he said that what all things were created by what? By a supernatural being, all right? So all of you that are conversant with Genesis, okay, and the story of of the creation, okay, this will not be much of a problem for you. We also have what the theory of spontaneous generation. Theory of spontaneous generation. Okay, it's also called what? Autogenesis. Okay, it's also called abiogenesis. Okay, so that is what the theory of what? Spontaneous generation, also known as what? Autogenesis. Okay, or what? Abiogenesis. We also have the theory of panspermia. Okay, theory of panspermia. Okay, the theory of what? Of panspermia. Okay, panspermia. The theory of panspermia. Then the theory of eternity of life. Theory of eternity of life. Okay, we also have the theory of catastrophism. Okay, the theory of catastrophism, and you also have the Oparin Haldane theory. Oparin Haldane theory. Okay, so these are what most of the theories, all right, that was what postulated, okay, to explain, okay, how life began, okay, the origin of life, theory of special creation, theory of spontaneous generation, also known as autogenesis or abiogenesis, theory of panspermia, all right, the theory of eternity of life, the theory of catastrophism, and the Oparin Haldane theory. So let's begin with the theory of special creation, all right. So the theory of special creation is saying that that life was created by God himself, all right? All right, a supernatural being, okay? That life was created by what? A supernatural being, okay, or what? A supernatural power. It says the entire earth, okay, was created in in few days, okay, created birds, created man, created all of them, and then on the seventh day God rested. Okay, I'm sure you are used to that story of of creation. That is the theory of of special creation, that God created the earth and all possible life forms, all possible life forms. Okay, that's the theory of special creation. The theory was widely supported by by a man called Father Suarez. Okay, Father Suarez was a Spanish philosopher, okay, and theologian. Okay, he was a Spanish philosopher and and theologian. Okay, he was a major proponent of this theory. He so much believed in theory. He lived from the year 1548 to 1617. Okay, that was Father Suarez. All right, please take note of that. Theory of special creation, widely supported by Father Suarez. But of course, as you see, the theory of special creation does not have any scientific backing. Okay, and that's why see, most scientists, they do not believe that there is God. Okay, but I believe strongly that there is a God, okay, up there, all right, that there's God. Okay, there is God. Oh, all right, so there is God. Okay, but it has no scientific backing, and so because of this, it was widely not accepted. Okay, it was not accepted at all because of there was no way to prove all of this, and since science has nothing to do with all of this, okay, it was widely not accepted. Now let us look at theory of panspermia. Okay, all right, so the theory of panspermia is saying that a large meteorite, okay, collided with the earth. Okay, a large meteorite. Okay, this theory of panspermia. Okay, so I say that what that a large meteorite collided with the Earth. Okay, a very large what meteorite collided what with the Earth. A meteorite is a solid piece of rock. Solid piece of rock. Okay, it's a solid piece of rock. It could also be what a metal, okay, that survives its passage, okay, through what the Earth atmosphere and lands on the Earth's what surface. Okay, a solid piece of what of rock or metal, okay, that survives. It survives what the Earth's atmosphere. Okay, and then what it lands. Okay, so it survives what the Earth atmosphere, all right, and then what it lands on what on the Earth what surface. Now, if it burns up, okay, this meteorite, if it burns up, okay, in the Earth atmosphere, okay, we call it what a meteor. Okay, also called shooting star. Okay, if it burns up in the Earth atmosphere, because a meteorite is what a solid piece of rock or metal that survives the Earth atmosphere and then lands, okay, on the Earth. All right, so if it burns up, all right, in the Earth atmosphere before landing, okay, it is called a meteor. A meteor is also known as what as a shooting star. But if it is floating in space, okay, it is called what a meteoroid. Okay, okay, a meteoroid, all right? If it is floating in space, it is known as what? As a meteorite. If it burns up in the atmosphere, it is known as a shooting star or what? A meteor. Along with what all of this will talk about what the meteorite, okay? The person who postulated this, okay, that is Richard and what are supported by Arrhenius, okay, is saying that what perhaps during all of this process, that the spores of life, okay, migrated, okay, might have migrated during this process, okay, to the Earth, okay. So they're trying to say it is that it is extraterrestrial, okay, extraterrestrial, all right. That's what they postulated, what the extraterrestrial origin of life, okay. So this is also called the planetary theory. Okay, this was theory of panspermia. It's also called the planetary theory. Okay, it's also called it the cosmozoic theory. Okay, cosmozoic what theory? Like I say, it was what postulated by what? By Richard, and then it was widely supported by Arrhenius. All right, so that is what the theory of panspermia. All right, saying that a large meteorite collided with the Earth, and we're saying that a meteorite is a solid piece of rock or metal that survives the Earth atmosphere and then lands on the Earth surface. Okay, and we say that if it burns up in the atmosphere, it's called a shooting star. All right, while if it lands on the Earth, it's called a meteorite. Okay, and they're saying that along with all of these, that the spores of life might have migrated, okay, from another planet to the Earth, all right, meaning that it is extraterrestrial, okay. So we have the extraterrestrial origin of life. Then it's also called the planetary theory. It's also called the cosmozoic theory. It was postulated by Richard and widely supported by Arrhenius. The Greeks believed that life on Earth came from the space, that life must have come from other planets in the form of spores, okay, that we're talking about, all right, that the life must have come from other planets in the form of of spores, and then after it came here, it evolved, okay. And then it evolved. This sport, it evolved after coming to the Earth. A lot of scientists actually criticize this theory. They are saying that there's no way that life, okay, from another planet will cross the Earth atmosphere and then come and land, okay, on the Earth. All right, there's no way life can cross another planet, pass the Earth's atmosphere, come and land on the Earth. Okay, the survival of that life, okay, is not even guaranteed. It's not possible, right? Because there must have been high temperature. Okay, there must be there must have been high temperature, there must have been even extreme dryness, all right? So many other factors, ultraviolet light, okay, that anything cannot even survive in all of these conditions, okay, even ultraviolet rays, okay, and anything ultraviolet rays, okay, there's no life that will be able to survive this extreme dryness, these extreme conditions, okay? So they criticize the theory. And that takes us now to to the theory of of spontaneous generation, okay? So please ensure you have liked this video, you have subscribed to this channel, and ensure you are sharing the link of this video to your friends and loved ones. Download the O3 Schools application, all right? And you see how good you have become within a short while. Okay, so let's look at the theory of spontaneous generation. All right, so in very old times, all right, remember it's also called theory of autogenesis. Okay, it's also called the theory of abiogenesis. Okay, so in very old times, okay, scientists believed, okay, that life must have been formed spontaneously out of non-living things, okay, that life must have been formed spontaneously out of non-living things, okay. This was their belief in the old times, that life generated automatically, okay, in non-living matter. Like for example, if there's a dung somewhere, okay, you know what a dung is now, like shit, that we call shit, okay, the one you go to toilet to release, okay, that if there's a dung somewhere, or maybe cow dung or something like that, okay, that if there's a dung somewhere, that maggots, okay, maggots, okay, will be formed automatically, okay, that if rain falls, okay, frogs will be formed, okay, automatically also. But these people didn't understand that life, okay, comes, okay, from pre-existing life, all right, that life is what is formed from from pre-existing life, all right. So life cannot come from from non-living things, okay, cannot come from non-living matter, all right. It is not the dung that is producing the maggot, okay, that's making the maggot to form, all right. It is not the rain that's making the frog to form, all right. So life comes from from pre-existing life. They fail to understand they fail to understand that if there is death, okay, if there's dung, okay, in a particular place, and there's food that has been prepared close to that place, okay, or you prepare food and you leave it close to that place, that flies will come. Flies, okay, would come. These house flies, they will come, they will lay eggs, okay, and then they will breed, okay, they will give birth to their offspring in that condition. That condition was only, or is only good, or for their breeding. Also, the fact that frogs, okay, are not born because of rain, okay. The rainy season, okay, is only suitable, all right, for their breeding, okay, is suitable for breeding for frogs, okay. So during the rainy season, the find water, they will go and lay their garments there, all right, and then they will now give birth to tadpoles, okay. So that is only they fail to understand that life comes from pre-existing life. There was that life comes from from non-living matter. It comes from from non-living things. Originates from from non-living matter. So the origin of life is not actually spontaneous, okay? It's not actually was spontaneous. At that time, okay, they believed that that a man called von Helmont, okay, von Helmont gave a recipe for rat production. Okay, they believed then, all right, that a man called von Helmont, okay, gave a recipe for rat production. What was this recipe? He said take an earthen pot. You know what to call an earthen pot now? Earthen pot. That one we call clay pot. Okay, he said put some wheat grains inside. All right, wheat grains. Okay, you should put some sweet grains inside, sweet ones, all right? Then carry a cloth, a dirty cloth, okay, a dirty cloth, and soak it in in water, and then put it inside this earthen pot, okay? That after 21 days, rats will be born, okay? So that was the recipe that that von Helmont gave for rat production, all right? He said, take an earthen pot, put wheat grains inside them. Also put wheat grains, okay? Carry a dirty cloth, soak it in water, put it inside the pot, come back after 21 days, you see that rats were born inside, okay? And truly, it happened. Okay, it happened, obviously. And when it happened, they say, oh, okay, it really happened. It lives on its own. But definitely, what could be the technical reason for this to happen? Okay, if you take an earthen pot and you put wheat grains, okay, in it, definitely it is normal that that rats will go in search of food, okay? So they will go to they will locate that earthen pot. Even the dirty cloth will attract the rats, okay? So when they get there, all right, they see food. They have seen an environment where they are seeing food, okay? And it's a pot, all right? They can release their garment there, give birth to young ones, okay? So they have found a good place to breed, okay? And and live, and feed, okay? So because of this, they will release their garment there and give birth to their young ones. Successful breeding and feeding are the two purposes of animal life. Okay, successful. Take notes. Successful breeding and feeding, okay, are the two purposes of animal life. And because they have seen a place where they can feed, they have seen a place where they can breed, then why would they not give birth to their young ones inside? Okay, so it does not really happen that it is this recipe that is bringing rats. Okay, it is only attracting them, okay, to the pot. All right, it is not producing the rats. So to say that life exist or form spontaneously, okay, from non-living matter is very, very wrong assumption. If you do not keep your food, okay, aside properly, then rats will come. They will come, all right? Corpse will come, all right? Even if you refrigerate your food, okay, complex life will not come. The rat cannot come to a refrigerator and go and form there, okay? But after a while, simple life forms can come, all right? So it is not what is it called? It is not this recipe that brings the rat, okay? It is this recipe that is attracting them, right? Because of successful breeding and feeding are the two purposes of animal life, just like I have highlighted. But please take note that at that time, they do not know anything about microorganisms, okay? So just like I'm saying that if you refrigerate the food also, okay, that complex life form like rat now cannot come there, corpse cannot come there, lizard will not come there, okay? But microorganisms, okay, can come out from there, okay? But of course, at that time, they knew nothing about microorganisms, right? So to disprove this theory of spontaneous generation or autogenesis or abiogenesis, okay, Francesco Redi, okay, now did his experiment. Francesco Redi's experiment, all right, was in order. So please ensure you download the O3Schools app, activate the app, and start practicing your way to success, okay? It's your sure way to succeed once and for all in this exam, right? So please do not joke with this opportunity, okay? So let's look at Francesco Redi's experiment. All right, now to Francesco Redi's experiment, okay? And of course, all right, sorry, this is Redi. All right, Redi. Okay, it's 1D, not 2D. All right, so this is the first controlled experiment, all right, in biology. All right, it's the first controlled experiment in biology. All right, and of course, it opened doors for other scientists like Spallanzani, like Pasteur, to also conduct their experiment. All right, so in those days, what was the belief It was the belief of theory of spontaneous generation, that life, okay, was formed, okay, from what? From a non-living what matter. All right. So Spallanzani, Francesco Redi tried to what? To change what that narrative by conducting what? An experiment. Okay. What was the purpose of this experiment? Is to show whether maggots on decaying meat came from the meat itself or from flies. Okay, so that's what the purpose of the experiment, to show whether maggots on decaying meat came from the meat itself or what from the flies. So what did Francesco Redi do? He took what? 3 jars. Okay, 3 jars. All right, the first jar, he left it open. It's one we call the open jar. All right, so took what? 3 jars. Jar 1, all right, is what? Is the open jar. Now, for the open jar, flies can come in and out of what? Of the jar. All right, so flies can come in and out. All right, then the second jar, all right, it took 3 jars, right? So the second jar now is what we call the sealed jar. All right, and of course, this sealed jar is what is completely what? Closed. All right, so okay, this one is completely what? Closed. All right, they will now have what? The jar that I covered with cloth, jar 3. Okay, the one we call the cloth jar. Okay, so, or the cloth covered jar. Cloth covered what? Jar. All right, now for the cloth covered jar, all right, air can enter. All right, but of course, flies cannot what? Enter into what? The jar, because what? This is a jar, for example, you covered it with cloth. Okay, all right, definitely hair can enter, but what? Flies cannot penetrate what? The cloth. Okay, so for the cloth jar, all right, flies cannot enter, okay, but what? Air can enter. All right, so this were the 3 jars that Francesco Redi took. Okay, jar 1, he left it open, flies can come in and out. Jar 2, it was sealed, completely was closed, flies cannot come in. All right, then we also have what? Jar 3, it was covered with cloth. Okay, flies can come in, but air cannot enter. For this sealed jar, even air cannot enter because it's completely sealed. Now, what did he observe? Okay, for the open jar, okay, he observed this first one. He observed that maggots appeared, okay, on the jar. Okay, why did maggot appear on the jar? It is because what? The flies, okay, the flies laid egg there. Okay, so since the flies can come in and out from the open jar, all right, so maggots will definitely appear, okay, on the jar. Okay, because what? Flies laid their eggs there. They also have jar 2, which was completely sealed. This one is completely closed. Okay, there was no maggot found there. Okay, so for the jar 2, all right, no maggot was found. All right, why is that? It is because what? It was completely sealed. Even air cannot even enter, not to talk about what? Fly. Okay, so maggot was not found there. All right, so that leaves us to what? With cloth what's it called? With cloth covered jar, the jar 3. On the third jar, okay, maggot appeared. Okay, maggot appeared on the cloth. Okay, on this third jar, okay, maggots appeared on the cloth, okay, but not on the jar. All right, so the cloth that was used to cover the jar, okay, maggot appeared on top of it. Okay, but inside the jar, they did not find any maggot. Okay, why would they find maggot on top of the cloth? Okay, it is because the flies can lay egg on the cloth, okay, but they cannot penetrate, they cannot enter into the jar. So this proved that the maggot came from from the fly eggs. Okay, it proved that that maggots came from what? From the fly eggs, and not from the meat itself. Okay, number one, it proved that what? That maggots came from the fly eggs, okay, and not from the meat, okay, itself. All right, so that's what the first thing that was proven. Okay, so after this observation, okay, conclude that maggot came from the fly eggs and not from the meat. But I said then also you also would prove what the theory of what? Biogenesis, okay, meaning that what? That life comes from pre-existing life. All right, so this what Francesco Redi's experiment that what opened doors to other what scientists, okay, like Spallanzani. Okay, because we're going to look at Spallanzani's what experiment now. Okay, let us look at Spallanzani's what experiment. All right, so at that time, okay, microorganisms began to what? Become a thing. Okay, so at the time of already, okay, microorganism started to become a thing. All right, so it was important for what? For sorry, pardon me. It was important for what? For Spallanzani to conduct another experiment, even after Redi as laid a groundbreaking foundation. All right, because Redi did not take into account what? Microorganisms, isn't it? All right, so now let's look at Spallanzani's experiment. Spallanzani's experiment. Right, so Spallanzani's experiment. Okay, so now what is the purpose of Spallanzani's experiment? Number one is to what? Okay, majorly, okay, is because he was trying to prove what? Microorganisms, okay, that they exist. All right, and of course, but that they do not also what? Occur spontaneously. Okay, so it was disproving what? Spontaneous generation for microorganisms. So the purpose of Spallanzani's experiment is to test whether microorganisms, okay, that is what? Germs, could arise spontaneously in liquids like broth. Okay, broth, broth, okay, is called nutrient soup. Okay, that is what broth is called. What? Nutrient soup. So the broth is what? Is like a liquid food, okay, that can support the growth of of microorganisms. Okay, all right, that's what the broth is called, the nutrient soup. So they will put water, use water, they use salt, they use would they use salt? Maybe not. Okay, but they use meat also. Okay, so it's called nutrient soup. Nutrient soup, okay, that will encourage the growth of of microorganisms. All right, so that is what the broth. So is to test whether microorganisms, that is germs, could arise spontaneously in liquids like what? Like broth. All right, so what did he do? What are the steps in this experiment? Number one, he prepared flax. Number one, steps. Okay, he prepared flax with broth. Okay, that is what? Nutrient soup. Okay, so now second step, he boiled the broth. Why is he boiling this broth? So number two, he boiled sorry, the broth. Okay, why is he boiling the broth? He's boiling the broth so that it can kill all microorganisms that are present in the broth. All right, so to kill all microorganisms in the broth. Okay, so that's the major reason why is boiling the broth. So number three, he sealed some flax. He sealed some flax completely. Okay, and then he left the others, okay, open to air, and left the others open to air. Okay, so this is what Spallanzani did. Number one, to test whether microorganisms, germs could arise spontaneously in liquids like broth. They prepared flax with broth, nutrient soup. He boiled the broth, he boiled it. Okay, boiling it will kill every microorganism. You know, there's some temperature, there's a temperature that those microorganisms cannot survive, so they must die. So he boiled the broth, okay, the nutrient soup. And then he sealed some flax completely, and then he left the others to be open to air. So what was his observation? Okay, so the seed flax, okay, the seed flax, he observed that no microorganism grew. Okay, the sealed flax, okay, he observed that no microorganisms grew, okay, in the sealed flax, okay, but in the open flax, okay, he said that he observed, he observed that microorganisms grew on it, okay. So for the seed flax, he observed that no microorganisms grew on them, while for the open flax, okay, he observed that microorganisms grew on them. Then he concluded that microorganisms came from air and not from the broth itself, okay. So his conclusion, okay, concluded that microorganisms came from air and not the broth, okay, and not the broth itself, okay. So he concluded that microorganisms came from air and not the broth itself. So he proved or disproved spontaneous generation for microorganisms also. All right. So that is that about the experiment of Spallanzani. But however, even after all of this, what people they feel they satisfy now. Okay. Some people said, okay, that is because he sealed the flax. And because air did not enter the flax, that is why microorganisms did not grow, okay, on it, okay, saying that microorganisms, they need life to form, okay, they need life, okay, so they need air, okay, so it is because he sealed it, that is why they did not grow on it, okay. So now Louis Pasteur, okay, now had to conclude all of this. All right, so let us quickly see the experiment by Louis Pasteur. All right, so Louis Pasteur concluded the experiment, okay, on spontaneous generation and proved biogenesis. He proved that life came from from pre-existing life. Okay, let's look at the experiment of Louis Pasteur. All right, so now after the experiment of Spallanzani, okay, what people said that why did he cover the flax? Why did he seal the flax completely? That life, they need air to form, okay? So Louis Pasteur now brought a total conclusion to all of this argument, okay? So what was the aim of Louis Pasteur's experiment? The aim is to show that microorganisms come from other microorganisms in the air. All right. So the purpose of this partial experiment to show that microorganisms come from other microorganisms in the air and not from non-living matter. Not from non-living matter. Okay, so that also Louis Pasteur's aim, okay, is to show that microorganisms came from other microorganisms in the air, okay, and not from non-living matter. All right, so now what are some of the materials that he used? Okay, number one, he used the nutrient broth. Okay, he used yeast plus sugar plus water. Okay, so this was the component of his nutrient solution. All right, use yeast plus sugar plus plus water. This was the component of his nutrient broth. Okay, so number one material, the nutrient broth. So the materials for this experiment, all right, number one is nutrient what? Broth, okay, also called the nutrient soup, all right? So we already know that, okay? They also use what? Flax, okay, with long what? Curved necks, okay? Number two, use what? Flax with long curved necks, okay? These flax were called what? Swan neck flax. You know how a swan looks like, okay? So something like this. All right, so this is how what it looks like, okay? All right, know how a swan looks like. Okay, so this is what how what the flags look like, okay? It is called what? A swan neck flags, also called a swan neck, SWAN, swan neck flags, okay? Then also he used what? He needed what? An heat source, all right? Because he needed to what? To heat what? This nutrient broth, so that what? All of what? All of the solutions, okay? And all of the microorganisms, any existing microorganisms will what? Will die first, okay? So first of all, you know, he has what? This long swan neck flags. They also have some flags that he broke what? The neck, okay? He removed them, okay? So that what? Air, okay, dust, microbes, all of that work will enter into the nutrient broth, all right? So, but he used what? This what? Swan neck what? Flags. So, number three, what did he use? He used okay, nutrient broth, flax with long curved necks, which is what? A swan neck flax. Then number three, heating source. All right, so he needed to what? To heat, okay, to heat what? The nutrient what? Broth, to kill all microorganisms, okay, like I said. All right, so he needed what? And heating what? Source. So what are the steps involved in this what? Experiment? Let's look at the steps. Okay, in what? In this experiment, all right? So number one, all right, he prepared what? The flax, all right? Prepared the flax with what? With the nutrient broth. So number one, he prepared the flax, okay, with the nutrient broth, all right? So he prepared the flax with what? With the nutrient broth. Then what did he do next? He boiled the what? The broth, okay? Number two, he what? He boiled the what? The broth, okay? What will boiling the broth do? It will kill any existing microorganisms, okay? This one is to kill any existing micro what? Organism, all right? So that is why what? He boiled what? The broth to kill all of them, okay, before he began his experiment. So thirdly, he left the what? The flax open what? To air, okay? Number three, he left the flax, okay, open to air. All right, but this time remember that using what? The swan neck or tube, okay, or the long neck tubes, all right, using what? The long neck swan, okay, tubes, all right. So that is what? Swan neck tubes, okay, long neck swan tube, or the long swan neck tubes, okay. So that was one what he was using at this point, all right. So with this now, air can enter. All right, this flask that is open to air, air can what? Can enter into the flask, okay, but microbes cannot enter, okay. Dust cannot what? Enter. The dust will be trapped, okay. This is how it looks like, okay. This is how it looks like. So the dust particles, okay, will be trapped somewhere here. Air can enter freely, all right. The microbes, dust will be trapped somewhere. They'll not be able to travel to what? To the nutrient was brought, okay. So that's what it does. So that's what it did rather. He left the flask open to air, so that what? Air can enter into the what? Into the tube, okay. But what? But microbes and what? And dust will be trapped, okay, at what? At the what? At the curve, okay, in the what? In the tube. Then lastly, he observed the flax for microbial growth, okay. Then number four, he observed the flax for microbial growth, Okay, so this was what it did. In the first step, he observed the flax. Okay, for what? For microbial growth. So what did he observe? Okay, observations now. Okay, so in the swan neck flax. Okay, he observed that what? No microorganism grew. Okay, so no microorganism grew. Okay, in the swan neck flax, even though air, all right, even though air entered, okay, into the flax, even though air entered into the flax, he observed that no microorganism grew. But in the flax, okay, with broken neck, in the flax with broken necks, okay, you observe that microorganisms grew. Okay, but why did microorganisms grew in the flax with broken neck? The flax with broken neck, we look like this now. This is the flax now. Okay, no, normally it's supposed to be a swan shape like this. Okay, all right. So because it broke it somewhere here, all right, so that now air can enter, dust can enter, microbes can enter. All right, so microorganisms grew. All right, in this flax with broken necks. Okay, and it grew because microbes were able to enter, dust were able to enter into the broth. So what was his conclusion? Okay, his conclusion was that microorganisms come from other microorganisms in the air and not from the broth itself. Okay, all right. So his conclusion was that microorganisms come from other, number one. Okay, that microorganism. Number one, conclusion, microorganisms come from other microorganisms in the air. All right. So that was his first conclusion. All right. That microorganisms come from other microorganisms in the air and not from the broth, not from the nutrient soup, not from the nutrient soup itself. So this put an end, okay, to to spontaneous generations completely. All right. And then proved biogenesis. Right. And proved biogenesis. Okay, so that is that for that concerning Louis Pasteur's experiment. So now let us quickly look at chemical evolution. All right, we are drawing close to where we stop for this class. All right, it is important that when you like this video, you subscribe, and share to your friends and loved ones. Okay, that's the only way to help us grow. Download the O3 Schools app and help yourself. Okay, that one is to help yourself. Don't download it. All right, pass your exam at once. That should be your mantra. That should be your only target. All right, so that is that for that. All right, so now let us look at chemical evolution. All right, that's Oparin Haldane. Okay, chemical evolution. Okay. All right, so this one is by Oparin Haldane theory. Okay, so that is Oparin Haldane theory. Please excuse me, let me change this marker. Okay. All right, so Oparin and Haldane, all right, they used their brains, okay, and said that that life on Earth must have been, okay, being as a result of problems with chemicals, with chemicals, okay, in the beginning, okay, that's what they said, all right, that life must have been, okay, as a result of problem, or life must have originated as a result of problem with chemicals right from the beginning. We call that concept, okay, the modern theory for the origin of life. Okay, all right, that's what their concept. Okay, the modern theory for the origin of life. That's what we call Oparin Haldane what theory. Okay, this theory was first of all put forward by Haeckel. Okay, Haeckel was the first person to put forward what this theory. But however, it was in a very crude form. All right, it was not detailed. Okay, it was not detailed, so it needed further experimentation, it needed further exploration, it needed further what analysis. Okay, and this was one that was now put forward by Oparin and Haldane. Okay, so that theory is called the modern theory for the origin of life. That theory was also called the chemical theory. Okay, it's also called the chemical theory for the origin of life. Okay, it's also called the theory of artificial synthesis. Okay, it's also called the materialistic theory. Okay, so the theory by Oparin and Haldane is also called the chemical theory. Chemical theory, that's what I call the chemical evolution. Okay, chemical theory for the origin of life. Okay, it's also called the theory of artificial synthesis, so-called what the materialistic theory. They stated that what life emerges from pre-existing non-living organic molecule. Okay, and life emerges, okay, from pre-existing non-living organic molecule. All right, so they stated that life, okay, emerges from pre-existing non-living organic molecules. Oparin was a Russian biochemist. Okay, Oparin. Okay, this one was a Russian biochemist. Okay, while Haldane, called J.B.S. Haldane, this one was an English physiologist. Okay, so that is what Oparin and Haldane. Oparin was a Russian biochemist. J.B.S. Haldane was an English physiologist. So they stated that life began on Earth billions of years ago, right, from non-living matter. Okay, all right, billions of years ago from non-living matter. Okay, but they said it was not spontaneous. Okay, not spontaneously. Okay, so they said that life, okay, began, okay, emerges from non-living matter billions of years ago, but not spontaneous. Okay, it was not spontaneously, and that the conditions of the primitive atmosphere there, okay, was very different than it is, okay, in the present day. Okay, the temperature was very, very high. Okay, there was heat from volcanic eruption, right? Molten lava, okay, scattering everywhere. All right, so these were the conditions then, all right, of the primitive atmosphere. And then there were gases, okay? Everything was in gaseous form, hydrogen, ammonia, methane, okay, and the likes, okay? Those are the gases that were present, okay, in the atmosphere then. And that there was lightning, okay? Lightning striking, okay? So that was the condition of the primitive atmosphere then. And the simple molecules like methane, like ammonia, like hydrogen, like water vapor, okay? Methane, okay? Ammonia, okay? Hydrogen, water vapor, that all of these, they kept meeting each other, okay? And then they now form amino acids. Okay, they form sugars, okay, and the likes. And then they say that life originated from from water, okay, because water is a very, very good organic solvent. That life originated from from water, because water is an excellent solvent. solvent, and that water provides what? Maximum chances for what to call molecular interaction. Okay, that water provides what? Maximum chances, because water is an excellent solvent. Okay, it provides maximum chances for what? For molecular interaction. This was Oparin and Haldane what view. Okay, JBS Haldane. Okay, he said that what? That the earth, okay, became like what? Like a hot soup. Okay, like a hot soup, okay, or one will call what? Primordial broth. All right, that the earth, okay, that it became what? Like a very, very hot soup. All right, like what? Like a primordial what? Broth, and that life, okay, originates or arises from pre-existing non-living organic what? Molecules. Okay, so this was what? This was the view, okay, of Oparin and what? And Haldane. So in summary, Oparin and Haldane, they gave what? The theory of what? Of artificial what? Synthesis. Okay, all right, which is what? This chemical evolution that we just what? Looked at. Okay, theory of artificial synthesis. Okay, but Oparin called this theory what? The materialistic. Okay, the materialistic theory. All right, so that is that for that. Okay, so the theory of the origin of life given by what? By Oparin and Haldane. All right, well, please do not confuse it with theory of what? Of species. Okay, we'll look at what? Darwinism. Okay, we'll talk about all of that. So let us look at Miller's experiment. Okay, so please are drawing close. All right, download the app, start practicing immediately. All right, like your life depends on it. Okay, let's look at Miller's experiment. So in Miller's experiment, after Oparin and Haldane, okay, gave the idea that what? That life could have arisen, okay, or originates from what? From pre-existing non-living organic molecules. Okay, they went to the laboratory to what? To test it, test it. Okay, that's why it's called the Urey experiment. Okay, so Urey was a student. Sorry, Miller was a student of Urey. Okay, it's called SL Miller. Okay, so Miller carried out the experiment under the supervision of what? Of Urey. Okay, and what was the aim of this experiment? The aim is to show whether the conditions of early Earth could produce conditions of early Earth could produce the organic molecules of life. Okay, just like what just like e.g. like amino acids. Okay, from what? From simple chemicals. Okay, from simple chemicals. Okay, so this was the aim of the experiment, to show whether the conditions of early Earth could produce the organic molecules of life, such as what? Amino acid from what? From simple chemicals. All right. So this was conducted by what? By S.L. Miller. Okay, under the supervision of Urey. All right. What are some of the materials that they use? Okay, they use methane, they use water vapor. Okay, they use ammonia. Okay, so they use methane, which is your CH4. Okay, they use what? Ammonia, which is what? Your NH3, they use your hydrogen, they use water vapors. Okay, they use what? Electric sparks. Okay, this one to replace what? Those lightning, okay, that were striking. Okay, so they built what? A closed case system. A closed case what? System. All right, and after all of their experiments, okay, they actually what? Proved, okay, that what? That life could arise, okay, from what? From a non-living what? Organic what? Molecules under the right conditions. That organic molecules like what? Like amino acid, okay, that are needed for life, okay, could form that amino acids, okay, amino what? Acids, All right, organic molecules such as what amino acid that are needed what for life could form, okay, under what natural condition from simple what gases and energy. Okay, so that is what Miller's experiment was about. All right, so now let us quickly just talk about what biogenesis. Okay, so biogenesis is talking about what that life comes from what from pre-existing what life, that the first non-cellular life forms would have existed like 3 billion years ago, and that the first cellular form of life did not exist till like maybe like 200 million years ago. Okay, that the first non-cellular life would have existed like 3 billion years ago, while the first cellular life, okay, will have what existed like 200 million years ago, and that they were probably what single what cells. Okay, and he said that what all life forms need what water medium. Okay, is trying to say that water is essential for what for life. All right, so this is where we're going to stop today. Okay, so in the next class we're going to be looking at the theories of what of evolution. Okay, Darwinism, Lamarckism, and the modern theory. All right, so stay put. I'll see you in the next class. Thank you for watching.